Hello, and in this video we're going to be looking at properties of a function. We're going to be looking at where the function increases. So we're going to be looking at increasing, decreasing parts, and when it's constant. And we're also going to be looking for local maximum values and local minimum values. Now I just generally picked up a function off the web. This was the platinum price in dollars per ounce from the years 1960 to 2000, right after 2005. We have a graph of the prices, and it's connected with the lines. What we're doing is we're looking at when the function increases. So we're looking at intervals where that occurs. So we're going to be looking at values along this axis where it's going to be increasing. So we could look at this. This looks pretty steep from this point to this point. Is going to be increasing. This is an increasing part of the graph. So our interval is going to be somewhere between about 1978 to this point here, which is going to be, looks close to 1980. So 1978 to 1980 we have this increasing amount. We also have an increasing amount here. We have a small increasing amount here. We have an increasing amount here. There's several places where this function increases. All right, and the decreasing amount is also occurs. So we can look at a value, for example, a decreasing value from this point here, so down to this value right here, which we're looking at an interval between maybe 87 to 1993. So 87 to 93, we have a decreasing amount of the graph. We can see that that's our interval down here. So our intervals that we're looking for are our intervals along the independent variable. Our independent variable being years here. Now if we're looking for constants, then we're going to be looking for flat places in the graph. So a constant would be somewhere where it's flat in the graph. So this could be constant. This looks pretty constant right here from 75 to 77. Looks pretty constant there. There's maybe a constant right here. So there's some constant to the graph. It looks pretty flat when it's constant. So that's increasing, decreasing, or constant. Now when we're looking at local maximum minimums, that's where we have the highest or lowest value at this point. So if we're looking at these values, this is a local maximum right here. At 1980 we have a maximum because it's increasing and then it's decreasing. So that's the highest point. This is a maximum here, local maximum. This is a local maximum here. This is a local maximum here. So there are several local maximums. Here's a maximum, here's a maximum. Okay. This would be a maximum at the end point. So those are all local maximums. Oh, I missed one here. Here's another local maximum. So we have several local maximum values that could be found along this graph. That's the highest point in its area. Local minimums are similar in that they're the lowest value in those areas. So here would be a local minimum, maybe. A local minimum here. Local minimum. Okay, local minimum, local minimum. So we have several local minimums. That's the lowest point around that area. So those would be, when you're finding local maximum minimum values, you're looking for when that value is the lowest in that area, and you'd give the independent variable or the domain variable for that local max and min. So we're going to look at another graph and find these intervals and look at these max and min points from another curve that's smooth. So we'll move on to this curve. We have a curve. This goes on forever. It has an arrow here. Goes on forever, increasing and decreasing wise. It continues to increase as we move along here, along this graph. So what we're doing is we're looking for amounts where we increase, the graph goes up. So what we're going to be doing here, since this has an arrow here, it's going to be increasing all the way along until it reaches this point. Then it decreases, so then it changes to decreasing. That's decreasing, and then it changes back to increasing again. So from that point on, it's increasing again. So we have two increasing intervals. So our first interval would start down here, which is going to be, in our case, negative infinity, because we keep going to the left forever. And then we would go to this value right here. So we're traveling along the x-axis. Our domain is along the x-axis. So we're going to go from negative infinity to 0 as our first increasing domain value, and we're going to have that with the interval from 2.4 to going forever to the right, so that's going to go to positive infinity. So that's going to be where it increases. From negative infinity to 0, that's these x values till where it increases, and then our y values. So we're looking at these values right here for our interval values. So x values are always our interval values. Now it's decreasing from here to here, so the decreasing values would be from 0 on the x value to the x value of 2.4. So that's decreasing. Now constant means it's flat. I don't see any flat, so there's none of these. There's no constant values, constant graphs. Now our local maximum is going to be the value found here on the graph. This is our maximum value. Okay. Let's see, we'll put that in, circle it in pink. So this is our maximum. Whereas this is going to be our minimum. So we would write that out as a local maximum of so our local maximum is 0.333 at x equals 0. So our local maximum can be found at x equals 0, and the local maximum value is 0.333. Now our local minimum value is going to be negative 1.971 at x equals 2.4. So we find the actual value. When we say we want the minimum value, we want the minimum y value, and we're going to, if we want to know where that occurs, then we write down the x value of where that occurs. So the local minimum occurs at 2.4, but the local minimum value is negative 1.97 or 1.971. All right.